Hello and welcome back to another episode of the Reliability Gang podcast. I'm here with my man Will. How you keeping, buddy?
Good, thank you.
We are back, and again, this podcast we're actually going to have a bit of a break-up within the reliability roadmap. We've been going deep, guys. We've been going like concepts, culture, strategies, all the different strategies. We've been going real deep with it, and there's a lot of technical kind of talk when we come to these podcasts, so we need a break. We need to chill out a little bit. So obviously within kind of this month, we are looking the end of the month to launch the repair centre. Everybody see obviously the pictures up online. Everyone see kind of the vision. We've not really given anything away inside of our kind of units yet. So we kind of done that for a reason, because what we want to try to do is do a bit of a reveal and kind of do a bit of an event with it all as well, which kind of leads us into kind of today's discussions. We're going to talk about that. We've got an exciting week as well this week, and we will.
Yep.
What are we doing this week?
We're taking a trip over to France. We're going to go see ACOM. So those of you that know, we use a lot of ACOM's equipment in a lot of the detect side of Maintain in helping us do our vibration analysis. And so we're taking a trip over to go see all of the different equipment, understand a bit more about MVX, Eagle and Sparrow, which are their kind of wireless continuous vibration monitoring solution. So just have a bit of a chat with the guys, go see the facilities over in France and get a bit of training so that we can come back and deliver to the rest of the team.
Exactly. And it's been exciting. We've wanted to do this for a while, to be fair, because obviously we use a lot of ACOM equipment for, especially Will said, the tech side of the business. We've kind of now set up a bit of a hub, analysis hub as well, where we're trying to feed in a lot of 4.0 data alongside a lot of our monthly data. We are going for a little bit of a transition now in terms of how data gets collected, and we are moving towards trying to find more efficient ways of collection, and B as well try to be able to actually take more data so we can understand what it means in them times in between. You know,
we're in that data-driven world now where lots of actionable data can be added together, and we need a place to be able to bring all that data in one place and have experts being able to review it.
Exactly. So that kind of reveals more to come on that later on. We have got the analysis hub set up. We are now looking to be able to obviously feed all that into Nest, and we've got some real cool plans with a web portal kind of based ACOM system that allows us to be able to really feed everything in. So this is where it's really exciting now as well, because for a while there was something missing from the ACOM online kind of monitoring framework, and they've just introduced it now. And I'm excited for this. So yeah, when we go there this week, it's going to be great just to learn as much as possible. So look forward to seeing you all in France this week. Back to kind of the repair centre side though anyway, so we are actually launching at the end of this month. So there's 2 specific days that will be launched pretty much now, and you'll probably hear the announcement before this even goes out. And them 2 days is where what we're going to do is invite anyone to come over to see the process from the analysis hub as well in terms of VA. We're going to have a lot of stuff to show in terms of vibration analysis and condition monitoring and precision maintenance. But more importantly and more excitingly, probably the other side, which is the repair centre, that allows us to actually take everyone through the way we're now able to close that gap on the solve part and actually start to repair motors, gearboxes, pumps, anything electromechanical, essentially is going to be able to go in there.
It falls into nicely that whole our motto or slogan that's on the website. And for those that haven't heard it, it's detecting the problem, which we do through the analysis hub. So we detect problems with pieces of machinery using diagnostics and data. So detecting the problem, providing the solution.
Yep, that's actually doing the work.
Doing it. So obviously once we go and we've detected potentially a problem with a piece of machinery, something that we were both taught during our mentors in engineering was, when there's a problem, guys, always come to me with at least one solution, which is what our engineering managers used to tell me.
I love that.
So
never problems, always solutions.
We want to ensure that we're going with at least a solution, and that might be an on-site repair or potentially even taking that asset out during planned maintenance to have it repaired by a
and it's good we have
facility.
The option now, because obviously before when we was on site we did a lot of kind of on-site bearing changes on site, because obviously that's generally the quickest and most efficient way of doing it. Do you know what I mean? But sometimes if there is the time and element to be able to take that away for overhaul, and you're able to as well test the motor windings, you're able to give it a good wash out, good clean out, revarnish it, give it a real good kind of almost like a bit of a prep up if it has to be repaired because the conditions warrant it. We've identified it from the detect side. At least in that can be overhauled now now even in an even more precise way from being in a workshop environment where you've got the right equipment and you've got the right conditions to be able to do so as well.
Yeah, and the last bit, which is, I think this is actually the most important, which factors into all this, which is, we like to say, improving reliability together. So in all of these kind of three aspects, the whole throughout all of it, it's about empowering maintenance teams to do precision maintenance and understand when the pieces of equipment do potentially fail. How do we facilitate the reliability processes? But this is also where the repair centre comes in key, because when we come to improving the reliability, when we have identified that a bearing may have a defect on it, and we've provided a solution in that motor there's a shutdown period coming up in the next few months, we're going to take the motor out of service, put a spare in, but we want to send this away. The next part, what we really want to be doing is understand, why did this happen in the first place, and what sort of things can we do with it? And the tricky thing is
it's the root cause of why we're seeing these things as well,
And for us in the past, that has been tricky, because often that motor is then sent to a repair centre that we don't have communication with. And as much as we beg and please can you ask them to keep the equipment, save the bearing,
can I see the bearing, please?
And sometimes, even though they have saved the bearing, there's telltale signs that are only visible during the strip down of the motor.
Because you need to inspect the housings, you need to inspect. That's the thing, isn't it? All that kind of work and all that information, when that does get stripped, is lost. There's a big part of it lost. So even if you keep the parts, that identify the defects, and obviously you can do root cause analysis kind of types with that as well. Of course, you can take that and have a look at kind of the reasons why. But you are right, Will. As soon as you just strip that, there's a lot of information in terms of even the feel of it, feeling the shaft, feeling the movement, any backlash. Do you know what I mean? Seeing if there's any housing deflection as well. And that is all done by the engineer or technician within that workshop environment as well. So, this is why for us it's quite exciting, because this really fulfills kind of where I've always had a passion for electromechanical work. When I was originally back in the workshop and I was rewinding, it is a beautiful kind of sense of feeling when you'd actually complete that work. It just gave you this sense of pride.
Especially taking something that is potentially broken. It's like upcycling equipment, to furniture in it. When you take that bit of it's got a broken leg, and you take it and you somehow transform it back into something nice again.
But do you know what is even more nice, actually? Obviously, seeing the work and seeing the wiring take form, and and then doing it all in a very neat and precise way, which again taps into reliability, because the more care you're taking with that aesthetics of it, do you know what I mean? The more precise that's going to be. Do you know what I mean? Like, even them small elements make a big difference. Small little inputs, large outputs. But it's just when you run that up and you see it moving after that, you've completely rewound it,
and it's just humming.
That's the feeling. That's the beautiful feeling. So, obviously, coming back to this, for me, it's always been something that we've spoken about. It's always been something that we've kind of thought about, because coming from that world was so passionate for me. And now this is why I'm so excited. And you can probably see the excitement in me.
And for the guys that are developing within the detect side of maintaining the analysis hub.
How beautiful was it, Will? When we took them, right, and this was the first week of January, we did some training, and we stripped some gearboxes, didn't we, together, kind of, we was in there, and when we showed them the wear, from what we detected from our vibration analysis on these 3 gearboxes, was just absolutely beautiful for them to see.
I feel like if anyone that's doing condition monitoring and analysis that isn't in an environment where they're able to do that, and we weren't in the past, like obviously you've come from the repair workshop as well, so when you worked at your previous employer, that you had repairs and you were doing CM, and when I was at mine, I had repairs. We used to do it in-house, a lot of our stuff.
But that's beautiful. You was doing it from on-site perspective, right? And that's something that I never had, because whenever we did on-site work, we were contractors coming on site. Whereas when you was empowered to do that, you was looking after your own maintenance. You know what I mean? And that was nice actually to hear about, even your story at British Sugar and how they did that, and how they kept a lot of them processes within the organisation. It's beautiful as well for the people that work there.
It allowed us to develop massively.
Exactly.
And that's where, for us as well, for our guys within the analysis hub and in that condition monitoring side of things, for them to continue to develop and improve, they need that confirmation.
100%.
I've seen there's a defect with the outer race, it's come through the workshop, and then we can go, look guys, you were bang on.
And do you know what though? But that's the beautiful thing as well. They can see the damage, because when you first get involved with vibration analysis, all you're seeing is numbers, metrics, graph, spectrums, and they obviously mean something after you see what they mean as a defect-related issue of a mechanical visual perspective of what that data actually means. That's what it means. So when you start seeing that, you can start to then visualize, well, what does that what does 1G in the envelope at the shaft speed mean to me in terms of damage though? And because these are the hard things to understand, because with VA, right, we're always going to get readings, right, that can be high. Right, but it's understanding what they actually mean in the mechanical value. Because some readings that might, for example, envelope is a great example, right? You could get your envelope ringing off, okay? But what is actually ringing off in that envelope? Is it an inverter? Do you know what I mean? Is it a housing defect or is it a bearing defect? Yep. And depending on them amplitudes, they mean different things. Yep. You know, a high amplitude with a housing defect might not necessarily have the same severity as a bearing defect that has an extremely high peak at that outer race defect, because that means you need to act a little bit quicker. Or what type of defect is it? Is it a cage defect, for example? Well, that doesn't mean you need such a high amplitude to justify the severity to do something about it. So this is where it's really nice to have a selection of bearings with damage. We've got the readings and as well the heights of them readings in terms of what they've reached as a reference point for the guys to really start understand. Because if I had that from my get-go, for the beginning, it would have fast-tracked me like tenfold, because it's the confidence to know what to say when you're seeing these things. Without the confirmation, it's really difficult.
It allows us to create the guidebook that we also have always wanted to create as well, so that we start to have the content to start putting. We've got the VA data, we just need the photographs to complement around
and the physical element around the repair side of it. So us being able to do all of that, even on the CM side, it allows them to learn a lot about the other. And obviously they are going to be two separate business models, but they're going to intertwine with each other so well. Because, you know, there's going to be a lot of communication in terms of when we find things, as the feedback of what is found to the technicians that allowed them to be able to understand the defects, that allowed them to be able to grow and understand it more. And they progress within their career, not just about becoming, like, I don't know, level 3 engineers eventually is where we want to push them all. Of course we do want to always push them, but more so in terms of experience, actual solid experience of seeing the defect from the creation. So the repair shop, this is why you can probably see the energy right now. I'm amped up for this repair centre. And the idea is, we really want to focus on that reliability element of everything we're doing.
It's important because fundamentally, those that have listened to the reliability roadmap podcast and are understanding a little bit more, and when it comes down to installing a brand new piece of machinery, or in the reliability's eyes, a machine that has been repaired, which we would consider almost as new, when we install that piece of equipment, there is a period of time where the reliability has the potential to be less.
Yeah. It's very true. And you'll notice on certain assets and certain plants where that point has actually probably happened. Yeah. Do you know what I mean? In terms of maybe it's a small process that didn't get done quite correctly.
All of that, that first early stage where there's the potential for an issue to happen, all of that usually is a contribution of a few different things, maintenance-induced issues. So has the repair been done with precision tools, or has the bearing been whacked on? Has it been a reputable repair workshop? Are they following the relevant standards? Has it been laser aligned? All these things, has it been balanced properly, contribute to there are so many opportunities there for the Swiss cheese to line up to lead to a maintenance-induced failures. Yeah. So, because of that was the reason why the repair centre was started, to ensure that we can do everything we can possible with a reliability mindset to ensure that we are minimising all those potential failure opportunities. Have we made sure the bearing installed in the right environment? Has it been done like this? Has it been installed using precision tools, so that when it is with the customer at site, whether we're going in to install it using laser alignment or they are, at the repair, everything's been done to ensure maximum potential life. It's like that whole.
It's almost like defect elimination on our part. Do you know what I mean? In terms of what we're doing, and when that comes in and thinking about, we're almost Famika in it. We're like, well, how could this fail, and how can we put an action in for each area? And even on the testing side, I mean, we recently received, thank you Mega, by the way, for the brand new ADX tester. Oh my God, like, when I received that, I was like, wow. So this is next level test equipment, guys. I'm literally, I'm going to do a full separate video on this, a YouTube video on how it tests and everything. Because you have to remember, guys, I was back in that workshop nearly 7 years ago. And actually longer than that. 7 years ago when I started maintaining. Oh my
changed.
God. I'm getting too old, man. Like, I'm forgetting, like, even when I started, like, it was good 10 years ago. 10, 13 years ago, actually. Jesus. So, exactly. I was in that workshop a long time ago. Technology's changed. Look at the analyzers that we've got now in terms of the as well online monitoring, very quick successions.
We spoke there obviously about that first early stage, and you mentioned about the ADX tester that we've got. How, as well as specifically that bit of equipment, how will that ensure that a customer that may send us a motor for repair, how does that help them?
Oh, massively. So the whole idea of this electrical tester is to really test a lot of different elements within the electrical winding. We all know in terms of looking at failure modes of how a motor can potentially fail. There's two main ones, I believe, that are quite important and probably the most common. Right. One being electrical failure. On the windings, on the integrity of the windings. The other one obviously being bearing defect. Yeah. That will cause potentially again though, it all depends on what happened first. So obviously if you get a bearing defect and it takes the windings out, well, that wasn't the root cause. The root cause is the fact the bearing failed. Yeah. But what we're doing when we're testing for the motor windings is to check. Generally that is a very huge part of that make of that motor, that winding. Yeah. Do you know what I mean? And what we're there to do is check the integrity of the insulation. Because remember, when we are winding a motor, we are winding a set of coils within that is insulated from the core. So obviously with these slots, what you've got is insulated Nomex material that insulates obviously all of that. So one test that is vital to understand is obviously making sure there's no surge current to air through the casing. So what the ADX does, it puts a lot of surge within the windings that allows it to be able to test up to 15 kilovolts. This thing's a beast, man, like a beast. Obviously we're dealing with a lot smaller motors in terms of what we're doing, but the idea is it can obviously test up for them larger motors as well, even on site. So we could actually now, I've got a bag for it as well, we could actually rock up to site and do a full motor test. Do a full motor test as well, and test for lots of different parameters to see the integrity and the health of the actual winding itself. And I do believe that is going to become a bigger thing as we move forward in terms, especially the bigger motors as well. And especially in shutdown scenarios and situations, okay, it may not have to be done every single month. It's not a kind of, it's still a condition monitoring technique, but you could probably do it once every, or twice every year. You know what I mean? And that would be a great way.
On your critical ones.
Critical assets, big motors, real critical ones, and you could do it in your shutdowns. So your shutdowns, you could pick 10 motors to be able to do this test, and you've got the information there, and you've got everything there as well, just to give it a bit of an understanding of where it's going to be. Because essentially, if you do have a breakdown installation or stuff, it's not quite failed yet, but it's potentially
going to start to see it.
You're going to see that again. It's a bit like a bearing defect, that defect initiation point to seeing that happen. Obviously, the more it heats up, and the more over time as well, vibration as well, micro vibrations into the core. This is why varnishing your motors is so important in terms of that having that real solid, hardening of the actual winding itself. Over time, it is going to fail. So the idea is it's condition monitoring for your windings essentially, and I don't think it's done often, but this is now another thing you can do on site. But again, in terms of, back to your question, in terms of the customer, when we get this device in, from one press of a button on the Mega ADX, which we'll do a complete video of all the different features what it tests for, can do a surge test that looks, puts current through the motors as well to identify any turn-to-turn shorts, any phase-to-phase shorts as well, because the three phases need to be isolated, and any kind of insulation defects or, within the core to earth, to the winding itself. And it does all of that within one.
So we're going to be able to produce a detailed report to ensure that the electrical integrity of that motor.
Oh, it's even better than this
perfect.
though. Yeah, even better than this though. Okay. It's got a cloud database. So now what we do, we create the customer. So say, for example, it's an ongoing customer relationship. We start building customers with our own customers. What we can do is set them up as a proper database, put all of them assets that come in from that, and it all logs it within the cloud, and it gives the history of them tests and when they were done, and all the figures from that test as well. So that's really great for like traceability and understanding when these things were tested and done. And this is something as well we want to be able to do to adopt for all of our customers, even new ones that come into the repair centre, is that we have a tab on everything that we've done with you guys, almost like a really robust CMMS system from a site perspective. We're going to have our own QA system in terms of understanding what's come in, what bearings were they, what winding type was it in terms of, is it 6-pole, 2-pole, 4-pole? Do you know what I mean? How was it wound? And all these metrics that we can actually import and put it into a database, for reference as well. So that's the beautiful thing about the tester as well. It also tests winding polarity. So if something's been rewound, it's been disconnected in a way, what it does basically, it tests the wave difference and phase difference between each winding to make sure they're 90 degrees apart, and then if it's okay, it says it's okay. If there is any slight error in terms of, say if it's been connected incorrectly, you're going to see a reverse polarity. So it tests for all of that. So obviously in terms of winding integrity and connections as well. And it does a high pot test as well, which is almost like a surge test, and it just puts a lot of current into the winding. And then basically what you're seeing is if there's any kind of turn-to-turn shorts as well, which again, when I was back in my old days, we had kind of 3 main testers really, and this does this all in one. So with a flash tester that did...
So you used to have 3 different pieces of machinery.
So what we did, we used a Mega to take all the, basically to check the resistances of each winding to make sure they're balanced. With a Baker tester, which is almost like a surge tester, basically. So Mega had bought Baker, I believe. Don't quote me if I'm wrong for that. So obviously the Baker tester does the polarity test and it does the surge test at the same time between the phases and the turn to turn. So the Baker still does a majority of the tests. Then we had a flash tester where we just basically ignite the casing and just tested the integrity for 1,000 volts through the casing just to check the insulation resistance through voltage as well. So them 3 tests were what we did. And this tester does actually more tests than that, I believe, in one press of a button.
That's pretty impressive.
It's very, very impressive. So anything that comes into the repair centre, and this is why, I mean, it was a big investment, of course it was, but I understand the importance of understanding that winding is so important. To that motor is so important. That winding is the heartbeat. Do you know what I mean? Of that machine.
Well, without it, it doesn't work.
Without it doesn't work. So we've got to understand the integrity of anything that comes in and understand there's a standard, and if it drops below the standard, we've got to be able to make it better.
So we've got that ADX tester now. That's going to ensure that we can make sure that any of our repairs, and not just that, so we're going to be able to test before, and if we need to do a repair, we can then test after as well. So we can ensure that what the customer is receiving it has a full comprehensive report for the electrical windings. What other kit should we explain to the guys that we've got that now can support us with the mechanical side, the bearings and things like that, because that's equally as important. We can do all that amazing work on the electrical winding.
Of course, yeah. And you're right, it's almost like 2 sections, isn't it? You've got the electrical side, and now you've got the mechanical side of understanding what's going on as well. And do you know what? In terms of the mechanical side, measuring devices are vital to be able to measure tolerances and make sure the housing tolerances are spot on. And again, this is where the measuring equipment and having that precision equipment is so vital. And not even that, having a standard in terms of what gets done with that equipment and when. So obviously when we strip a motor, we've got a complete kind of standard. And what we've done, we've obviously used experience that I've used in the past in terms of, I remember all that. I remember, like, literally in my head, I can even remember the job card in my head. Yeah. Because obviously I did it for so long. But what we're doing now, even from that, and as great as it was, there was a lot of things that weren't on there. That should have been. Do you know what I mean? And this is a big company, you know? But regardless, things have made a change from them as a while back. But now that we're thinking as a reliability-centered way, it kind of changes your mindset in terms of just repair. Because you can get a good standard of repair. We know that. Do you know what I mean? And it can be done. But we're not just that. We're looking at the next level, right? We're looking at precision now. So it's a bit like when you go to site and you get a rule to align your motor. Well, it might be bang on to your eye, and that might be considered your standard. But our standard is precision alignment to, 0.01 of a mil. So this is the difference now in terms of that. And it's the same mindset that needs to be applied when you're looking into this repair shop. So the measuring equipment is vital.
So that's for measuring the housing to ensure that it is within tolerance for the bearing and the shaft.
And the shaft as well, so measuring shafts.
For the inner race of the
bearing. For the inner race as well. So you might have a little bit damage on the shaft as well, whatever, and we need to make sure that there's tolerances set. Do you know what I mean? And they're well past before we move on to the next stage, because any problem there is going to present itself as a defect in the future. This kind of then goes through our defect elimination process of every step of the way that allows us to understand how could this be a problem in the future, because if we're not thinking that way, we're not thinking the reliable way. And this is the thing now, like even our mindset has to shift another gear, up a gear, do you know what I mean? Because there's a lot of scenarios and cases where it'll be easier not to say there's something wrong. Because it causes
especially,
problems.
I suppose, from an economical repair. Like sometimes it may be that, we'll just slip the bearing on and then we can charge the customer and then we can get it done, rather than actually tell them, look, you're going to have to remachine the whole shaft.
Exactly. And that's the thing sometimes, and it's just having that mindset of making sure we can do it in the most reliable way possible. So measuring equipment, obviously, calipers, verniers and all that type of
We've got a digital one as well, haven't we, that lets us do the housings?
We've got a digital one as well that allows us to do that, and obviously measuring different types of different measuring equipment. So, and obviously standards behind that, so measuring vital as well. Obviously bearing heaters as well. We've got SKF bearing heater as well. Everything is going to be,
So
nicely
induction
secured.
heated.
Induction heaters that we're going to use every single time. No opportunity then to get cocked bearing. No opportunity to get impact or defect in the bearing when you knock it on as an impact. That can always cause infant mortality later on down the line as well, in terms of even when it starts up, the risk then increases massively for that as well.
When a motor comes in, we see this quite a bit. What are some of the things that we need to be looking for that then will factor into the improved part?
Into the root cause analysis,
We see quite a lot with like belt-driven applications and like lube issues. What are some of the things that you'd probably expect to come in that everyone else can be looking out for?
Yeah, because again, this is another thing that I've considered massively, because we've been on site and we do a lot of work with application changes. So where they've had a motor in the past, for example, I'll give you a perfect example of this. One of our customers, we did a bearing change on site for, and it was a pedal press, and it was straight coupled, right? We obviously had a look at the nameplates, and we started to take the information. We realised that there was actually a roller on the drive side of the bearing. Because of this, we was getting a lot of chatter within our readings, because basically
it was skidding.
Well, it was almost skidding, because with a roller, the clearance is a lot more to be able to take up the actual, the load, the radial load. But obviously, when you've got a straight-driven application, you need finer tolerances, because if you kind of get it within the middle and you're going to have that chatter. It's not going to have any kind of
preload
or preload to be able to load the bearing up to where it needs to be. That's really, really bad as well for the bearing in terms of skidding, because what you can't do is when you grease that motor is engage that film, because it's skidding.
Around.
It's just slipping about. Whereas when you kind of then put a little bit of load on it, then obviously the film can be compressed, then causing the film. So what this can actually appear as is poor lubrication when there's a lot of grease in the bearing.
Yeah.
Does that make sense? So you're going to have to almost over lubricate it to kind of almost fill that film a little bit, which is never a great idea. So obviously from that application, we said, look, this should be a ball. What has happened is they've had a spare motor, and it was obviously for a belt-driven application before. They've kind of swapped it around the process. This is very common at older sites, 50 to 60-year-old sites with a lot of older equipment, very common. Where things have been used, or at the time they didn't have the budget, and they've kind of swapped one over.
Or even sometimes newer sites that don't really know what they're doing.
Yeah, that as well. That's less common. But it happens. And this is the thing as well. And the thing is, right, until you understand it, it is an easy thing to mistake.
Until you talk,
because you need to know. You need that knowledge. You need that awareness.
Industry changed as well, didn't it? Because years and years ago, you called up for a motor, and they asked you, what application is this?
But now they just say, okay, what is it? Give me the nameplate, and they just provide it. But that's where we've got to come in here as well. And this is a perfect example of when we do get something come in, we need to have that focus call conversation with someone who it is. What's the application? What is it doing? Rather than just repairing it, let's understand what it does, right?
Yeah.
We are literally dedicated to that as well. And excitingly, we have gotten a new starter. He started this month. Harry Crane. Won't leave you guys any guesses who that could be. But he started, and he's very passionate about making this work. And I'm very excited, because he is an incredible
and he comes with
engineer.
the mechanical background that we needed.
But that's the thing. I went out to job with him the other day. It was a fan application, and albeit he's not been in electromechanical, he's obviously been kind of fixing
in
agricultural industry. But I'll be honest, in terms of what he's been dealing with, is probably far more complex than what we are usually kind of doing as well. So on that job, we had this fan. He did an amazing job. So he's going to be heading this up with me. We're going to be working very closely together, and it's exciting. It's really exciting for him as well. But in terms of like getting back to our point earlier, in terms of the application, see, again, we go on these tangents, guys. I don't know how that ended up there. Back to the conversation on the application change, is that obviously when we notified it was a rider, we said, well, we need to put a ball back in. We need to put it back right. And we precision aligned the drive. From that point, we've never received the issue or problem with that bearing since, because we've used the right application, we've used the knowledge that we know in terms of doing it, but not only that, we've used precision maintenance. That's the main ideal when it comes back in. So that's the reliability offering. So now that asset, right, is going to be more reliable than it was before. That is our aim. Because if we can do that on your critical assets, then the value just literally tenfolds.
Yeah.
It's like 1 + 1 = 5 when you do that. When you precision, the most critical ones.
We're there as that piece of accountability. We've talked about this before in other podcasts about having someone, and it's why when we go in and now we're doing a lot of implementation of reliability, we are there positioning ourselves as really the facilitators, providing the training, empowering the teams to start thinking a bit differently. Same with the engineering services. Sometimes we've got customers that don't have the resources to do some of the larger jobs, but we do, and we also have the expensive pieces of equipment to allow us to do that.
And that's the thing as well, like when we've bought our equipment, me and you've always had the conversation, like what does this bring reliability in the future?
Yeah. How does this add more value to our customers?
Exactly, but every time we've done it, we've always spent more than we want to, but we understand the longer term goal in terms of what we're doing. Do you know what I mean?
Yeah.
Like even like looking at this ADX tester, it's a lot of money. And for your first surge tester, you know, I could imagine a lot of repair shops don't even have one of these, and they've been probably. And I'm not even picking on that because it's a lot of money. Do you know what I mean? So this is what we're doing now. We are really investing within maintain for the future for reliability as well. And this is another thing as well that, you know, I can't stress that as a company. We're really putting all of our eggs in that reliability basket. We really
It's about
are.
for us, and we did it we did a presentation at the start of the year to all of the guys working for Maintain now about the business culture. And for us, it's all about how do we be. It's not about being the biggest. It's not about having lots of quantities going through the repair centre. It's about not being the biggest. It's about being the best.
Yeah.
And look at every aspect and service we provide, and it's why we try and stay fairly independent, although we use a lot of AquaM equipment. That's because me and Will truly believe right now it is the best piece of equipment on the
100%.
market.
And that's the thing as well, it's about looking at each division. I mean, obviously we work with UB Systems as well.
Yeah.
Do you know what I mean?
Best
We work with
ultrasound equipment.
Hansford sensors as well. You know, all of this ties into that reliability network. And with, you know, all of the decisions that we've made have not been easy ones because we've looked at the whole market. Like, we've not just teamed up with anyone.
And that even comes into the reliability roadmap, which is, you know, looking at who your suppliers and vendors are, and do they conform to your standards?
100%. But we got if their standard is not there, we create it. And that's what we're trying to do in terms of saying, look, you know, the thing is, I get there's ISO, there's all these things that have been made before, but when we make this standard, the maintain standard in terms of the repair, precision maintenance stuff, we're going to understand that every single thing that we've inputted into that standard actually makes a difference. Does that make sense? So you've got all of these different things, but that mindset, which I think is ingrained in our culture now, that's our culture, is going to be able to allow us to be able to, no matter what it is, whether it is finding your problems in terms of vibration analysis, whether it's doing an air leak survey, whether it's doing a thermal imaging survey, whether we're actually on site changing the bearing and doing it in the most precise way possible, whether it's that we're doing a fan balancer, we want to balance that we want to just keep going. We want to put another trim on because you know what, it ain't good enough. We need that standard. When we're doing that, when we're in the repair shop and we're actually putting bearings on and we're taking them off in a nice, controlled, precision, safe
clean environment
as well. And every single step of that repair is looking at how can we, every little action is actually done in terms of making that more reliable for when it leaves. And that's the culture that we put around all detect, solve and improve. And with that, I think that's a perfect way to kind of end the podcast. Guys, thank you for listening. Thank you for the updates. Keep your eyes, ears peeled this week. All the announcements will be going out. We'll be inviting everyone over. It's been crazy. It's been hectic, but we are there. We're ready to go and we're really excited to show everyone everything. So guys, have a great week. Take care.